Hello there, my name's Gary Sims and this is Gary Explains. Now, following my videos about how Android uses its RAM, how iOS uses its RAM, comparing how Android and iOS use their RAM, someone said in the comments, why don't I look at how Linux and Windows use their RAM? The RAM management of Windows and of Linux, is there any difference? Is one better than the other? Well, I've done some testing and I've got some very interesting results. So if you want to find out more, please let me explain. So Windows and Linux are both full multitasking operating systems that use virtual memory. What does that mean? Well, it means if you have a program running, a process it gets called, or a task in the Windows world, let's say number 101 is running, it will have an address range from 0 right up to, let's say, 4 gigabytes, and address 16384 will exist in task 101, and address 16384 will exist in task 201. And they're not obviously using the physical RAM address of 16384. That's mapped, that's virtual memory, it's mapped through to physical memory, and that's done in hardware using the MMU, that's the memory management unit. And basically the operating system, whether that's Linux, whether that's Windows, says to the processor, look, when you hit this address, really it's mapped through to this physical address. And the memory tends to be divided up into pages, let's say 4K a page, and they're all littered through the whole physical memory, and the processors are kind of take blocks of those memory. And when a virtual address is used, the MMU actually has that mapped through to a physical address, so data can be read and written back to that address, and it all happens because these tables have been set up. Now, if you'd like a video about virtual memory, do let me know in the comments below, and I'll see if there's enough interest to put one of those together. Now, both Windows and Linux use this virtual memory management system. In fact, it's pretty common across all operating systems, Mac OS, FreeBSD. They all use exactly the same idea. Now, there's a second stage to this, and this is when you don't have enough physical memory for all of the actual programs that are running. Then you have the idea of swapping. And what this means is that when there's not enough space, some of the memory is taken from the physical memory and copied onto, let's say, the hard drive. And then that space is then freed up. And then if you need that memory later on, it gets read from the hard drive and put back into memory. Now, way in the day, this was mega important because, you know, machines had a much smaller amount of physical RAM. And if you wanted to run bigger programs, you wanted to run multiple programs, you wanted to run a multi-user system, then swapping was a real thing. It's less important nowadays. Even, you know, on a Raspberry Pi, you can get one with 4 or 8 gigabytes of RAM, and, you know, you may not see any swapping happen at all, just depending on your usage. So swapping is not quite so important as it was, but still important. Now, Windows and Linux again do swapping in a very similar way. Windows tends to just use a file, so there's a file on the disk that is allocated for that swap memory. Linux can also use a partition. You can tweak the parameters on both systems. For example, on Windows, you can create specific drives to have specific swap files on them. You can do the same on Linux. On Linux has the idea of swappiness. How quickly will the memory start to get swapped out to hard drive? So there are all these tweaks and things. But as I said, it's not so important today as it was in the past. Having said that, on my Windows PC, if I'm running, like, you know, Photoshop and Premiere Pro, and then kind of Chrome with lots and lots of tabs open and a few other programs, then there are certainly moments when if I switch from one task to another, it does take a little while to come up because the system has actually done some swapping, because obviously video files and photo files can take up a lot of memory. So what testing have I done? Well, obviously we're comparing Windows with Linux, but I've also been testing Windows with an x86 64 processor, 64-bit Intel or AMD processor, compared to Windows with a 64-bit ARM processor. And likewise, I've been comparing Linux with an x86 64 processor with Linux running on an ARM processor to see what the differences are. And then I've also compared Windows and Linux itself. Now, the first thing we'll look at is how much free memory is there when you freshly boot up the system. And let me point out, I've been using basically pretty much freshly installed systems. This is not something where I've installed loads and loads of other services, you know, Steam and running in the background and, you know, who knows what else. This is pretty much kind of fresh installs to see what these systems do. So I've been using Windows 11 on x86-64, Windows 11 on ARM64, and then Pop! OS, which is a Ubuntu derivative, on Linux for both x86-64 and for ARM. So here's our first graph. As we can see, the top two lines are for Windows, x86-64 and ARM64, and both of them, when you boot them up, they have just over 4 gigabytes of used memory. So one of them has 16 gigs, the other one has 8 gigs, and as you can see, 4 gigabytes of that is used even when you just start up from fresh. Now at the other end, we've got Linux running Pop! OS, both again on x64 and ARM64, and as we can see there, under a gigabyte used on the x86-64 version, just over a gigabyte used on the ARM64 version, which means clearly there's more free RAM when you boot up a Linux machine compared to when you boot up a Windows machine. Now it is worth noting here that free RAM can sometimes be a fairly complicated thing to understand. For example, if you have a machine that's up and running, it may use some of the RAM that's not being used for caching. So as it's reading files from the disk, it's keeping them in memory. There are other things that happen, for example, like when you have two processes and one creates a child process, and some of the memory is shared between them. And so trying to work out the actual free RAM can be a bit tricky. Sometimes it gets called available RAM, because available RAM would be where you could quickly kill off the cache because you don't need it, and you could use that space instantly for another program. So free RAM, available RAM, they are quite common, but I've done my best to find out the actual amount of RAM that's being used by programs, ignoring caching and trying to minimize the impact of shared memory. As we saw in that last graph, Windows is a bit of a hog. Now the next thing to look at is to see whether there is a difference between x86-64 and ARM64. Does one of them use more memory, kind of, just intrinsically has to use more memory than another? Well, let's have a look at some graphs. And so here's our first graph between Windows x86-64 and Windows on ARM64. The first example here is Firefox with two tabs open, one of them to Wikipedia, one to a popular news website. And as you can see, very, very little difference between them, both using roughly the same amount of RAM, down to a few kilobytes really between them. And the same when you're running VS Code, that's the open source version of VS Codium, because there's a build for that available. And I'm also making sure I'm running exactly the same version, because I'm taking that VS Codium build and running it. And again, you can see very, very little difference. In fact, slightly less memory used on the x86-64 version, but again, just about a few megabytes, not very much difference. So there isn't a huge difference between x86-64 and ARM64 in terms of memory usage on Windows. And what about on Linux? Well, again, we can see a similar setup here. The first example there is Firefox with one tab open on a Wikipedia page, actually slightly more memory used there by ARM64. And then LibreOffice Writer there with a blank document, just start up the program. Again, very much the same amount of memory usage between the two architectures. There was a bit of a difference here between VS Codium. The x86-64 version used less, what we got around 425 megabytes there, and it was just over 500 megabytes on the ARM64. But I think we can see in general there isn't too much of a difference between the memory usages. Okay, so we've looked at the startup, how much memory is free on both operating systems when they start up, what it's like comparing it across two different architectures, and now our third point is to see how do the same programs, let's say Firefox, running on Windows and running on Linux, how do they compare? So let's have a look. So this is all going to be x86-64 versions, because we've seen there's not really much of a difference between the two architectures. And so the green lines here are Windows, the kind of purple or mauve lines there are Linux, and we can look at the first one, Firefox version 97. That's why it's called, I've written that there, blank tab, nothing else. Obviously you can see very quickly Linux is using much less memory than the Windows version. Open up a tab, Wikipedia, again the Linux version is using much less memory. Two tabs, the Linux version is using less memory. And you go for LibreOffice Writer, blank document, just start it up again. Linux using much less memory than the Windows version. I open up a big docx file, again the Linux version using much less memory. When we come to VS Codium, it seems to be fairly similar here, not much to choose between them. And then for my final test, I got up Blender, of course, a very famous open source product for 3D graphics and so on. And again, the Windows version was using more, even just by starting it up. When you open up the Lone Monk a demonstration file, which you can get from the Blender website. Again, the Windows version using much more. And when you actually start to render it, well, the difference was quite amazing, because we're looking at over 2.5 gigabytes for the Windows version, more like 1.7, 1.8 gigabytes for the Linux version. So a significant difference there in the memory usage, and all doing the same thing. These are exactly identical tasks between the two. Now, I always knew that kind of Windows was probably a bit of bloatware, but I was shocked by just how much it is when you look at all those different programs. You know, Firefox, Blender, particularly Blender, when it was doing that rendering, there was a significant memory difference there between the two. So it's really interesting that if you are choosing between a Linux system and a Windows system, and you can do both tasks the same on either system, then the Linux system is going to be more efficient. Now, some people are going to write comments like, news, Linux is more efficient, water is wet, and all that kind of stuff. Well, yes, that may well be true, but now we actually have the proof to show that it is true. Okay, that's it. My name's Gary Sims. This is Gary Explains. I really hope you enjoyed this video. If you did, please do give it a thumbs up. If you like these kind of videos, then stick around by subscribing to the channel. Don't forget, you can follow me on Twitter at Gary Explains, and I also have a monthly newsletter. Go over to GaryExplains.com, type in your email address, no spam, but you will get the newsletter. Okay, that's it. I'll see you in the next one.